Okay, I'm going to finish up the practice test here from the pre-calculus textbook. We want to graph this function, 2 tangent of x over 2. A really doesn't affect the tangent. There's no amplitude. The only thing is if A was negative, it would flip it over the x-axis. The period, on the other hand, the period for tangent is not 2 pi over b, it's pi over b. So you get pi divided by b, which is 1/2 here. Dividing by 1/2 is the same as multiplying by 2. So the period is 2 pi. I would go half the period to the left, half the period to the right, create vertical asymptotes. And it looks a lot like a cubic. It'll come like this, and it does repeat. I'll be happy with one cycle, but that's tangent. Now cosecant's a little harder, a little different. Cosecant is 1 over sine. So I'm going to start off by sketching a dotted sine wave. But it's negative, so this could be 1 over negative sine. So I don't really want a positive sine graph. I think I want a negative sine graph, which means it starts downward instead of upward. So that's a negative sine wave because this is 1 over a negative sine. Now remember, it's a sine bx. Amplitude is the absolute value of a. So in this case, the amplitude I believe to be 1. The period, because it's a sine cosine, it's not a tangent basically. The period is 2 pi over b. So you have 2 pi divided by b happens to be pi. So that makes your period 2. So that's where it completes it. Half of it is 1, 1/2, 0 halves, 1/2, 2 halves, 3 halves, 4 halves. So I've graphed 1 over the negative sine of pi x. 1 over sine is, you cannot have 1 over 0. So where these hit the 0 or the x-axis, it creates vertical asymptotes. And the curve comes off of the sine wave and approaches the asymptotes. So let me do this in a different color here. Let's do it in red. It would go off of the sine wave and approach the asymptotes. So the graph of cosecant is really this red curve. This point would be 1/2, negative 1. This would be 3 halves, comma, positive 1. And that would be one cycle. Now on this one, we want to do the tangent of the arc cosine of negative 1/2. So to do this, I have to realize the angle whose cosine is negative 1/2. Cosine is the x. It's negative in quadrant 2 and 3. But if you remember, our cosine can only come from 1 and 2. So it's in quadrant 2. So I'm going to make my angle. I'm going to label it theta. Cosine is adjacent over hypotenuse. Okay, so I knew it was an arc cosine. Arc cosine only comes from quadrant 1 and 2. Because it's negative, it's in quadrant 2. Cosine is adjacent over hypotenuse, so I set it up that way. 4 minus 1 makes this side radical 3. So I want the tangent. So right now I need the tangent of that angle. Tangent is opposite over adjacent. So the opposite is radical 3. The adjacent is negative 1. So the simplified answer for this would be negative radical 3. 19, I have to make an angle. Whenever you have an inverse trig, such as an arc cosine, That means the angle whose cosine is x over 3. So I'm going to make an angle, triangle, angle, right angle. Now I need the cosine to be x over 3. Cosine is adjacent over hypotenuse. Do Pythagorean theorem and you'll get the square root of 9 minus x squared. Legs squared plus legs squared equals hypotenuse squared. If you solve it for y, you'd have to subtract the x squared and then take the square root. Anyway, we want the sine. Sine is opposite over hypotenuse. So what's opposite would be the square root of 9 minus x squared over the hypotenuse, which is 3. So it should be something like this. After 19, we have 20. They want us to solve the triangle. They already give us some of it. They tell me angle A is 21 degrees, so I'm going to go ahead and label it. I know that angle C is marked to be 90 degrees. You know the total degrees in a triangle is 180. 21 and 90, I believe, are 111. If you subtract that from 180, I think it gives you 69 degrees. So that makes this angle up here 69 degrees, which should be angle B. So that'd be 69 degrees. They already tell me side C. Side C is opposite angle C. That's a 13. Now I need to find like angle A. If I did opposite and hypotenuse, that would be sine. Sine of theta equals opposite over hypotenuse. So the sine of what angle, 21 degrees, equals the opposite, which is A, divided by the hypotenuse, which is 13. Cross multiply, you'll get A to equal 13 times the sine of 21 degrees. So if you multiply these and you are in degree mode because you're using degree measurements, you get 4.658. Well, I'm going to call it about 4.6. So A is about 4.6. At this point, you could do Pythagorean theorem to get the missing side. It is a right triangle. But why don't we just use our trig? Cosine of an angle is adjacent over hypotenuse. So the cosine of what angle, let's use a 21 again, equals the adjacent, this time the adjacent is B, over the hypotenuse of 13. If I, hang on. So if I was to solve for B, if two fractions are equal, you could cross multiply, giving you 13 times the cosine of 21 degrees. 13 times cosine 21 degrees gives me 12.136. 12.136, so I'll call it 12.1. 12.1. Now, with the biggest angle, is the biggest side opposite it? Looks to be true. Smallest angle, is the smallest side opposite the smallest angle? Yes, I always do that as a check so I know I have it solved correctly. Okay, for 21, I'm going to read the question. The angle of elevation to the top of a building from a point on the ground 30 yards from the base is 37 degrees. Find the height of the building to the nearest yard. Angle of elevation is how far it is above the horizontal, so that would be this one. And I want to find the height of the building, the blue building, H, if this is 30 yards from here to here. So that's adjacent and opposite. That suggests to me to use tangent. Tangent is opposite over adjacent. So the tangent of what angle, it appears to be 37 degrees, equals opposite, which is H, over the adjacent, which is 30. When you cross multiply, when you can solve this, multiply both sides by 30, gives you tangent of 37 degrees times 30. And when I punch this in degree mode again, because I'm in degree mode, 30 times tangent of 37 gives me 22.6. 22.6 approximately. Now it says to the nearest yard. So their answer is going to be 23 yards tall for that building. For 22, you have a 73-foot rope, which is the white hypotenuse here, from the top of a circus tent pole is anchored to a flat ground 43 feet from the bottom of the pole, like I have labeled. Find the angle to the nearest tenth of a degree that the rope makes with the pole. The rope and the pole, I believe, are up here. So that's the angle I want to find. From that angle, that's opposite, and that is hypotenuse. That implies sine. Sine is opposite over hypotenuse. So the sine of theta is equal to the opposite 43 over the hypotenuse 73. Now, if you ever need to get rid of a function, you use its inverse function. So to get rid of sine, I'm going to take the arc sine. If I do it to one side, I have to do it to both sides of the equation. Sine and arc sine eliminate each other. So I'm going to punch this in. Arc sine 43 divided by 73. And that gives me 36.08. And since I'm in degree mode, its answer is in degrees. So to the nearest degree would be 36 degrees. However, they don't want it to the nearest degree. They want it to the nearest tenth of a degree. Tenth of a degree, basically, you'd look right here, and that 8. Does that 8 round it up? So yes, this is going to become rounded to one decimal place, 36.1, and it would be in feet, right? Now, how would you describe this bearing? If that's 10 degrees, that means this would be 80 degrees. So if you started north and then went 80 degrees to the west, that's the answer the textbook has. Suppose you started to the west, could you go 10 degrees to the north? Nikki, everything all right? We're not supposed to share that. They actually want us to be very careful with this. Huh? 3455. That's not the new one. There's one that really want trying to protect.